Uh, Hello students, today we are going to start with real analysis solutions. The questions that have occurred in JAM 2021 in real analysis section are certainly difficult because seeing the last a few years pattern, one can see that the level of the paper is quite high with respect to the previous year question. So if you've not been able to crack a few questions in real analysis, don't feel bad about it because this is how the paper was. Okay. So let us begin with questions that have been asked in the examinations. Let us start. Okay, so the first question is question number 3 that is in your paper, IISc website paper. So question that was asked was, if function is defined from R to R and f is continuous, then f is not necessarily bounded. There exists unique x naught such that f of x naught plus pi is equal to f of x naught. There is no such x naught, and there are infinitely many x naught such that f of x naught plus pi is equal to f of x naught. So I've also maintained this particular thing in my classroom program also, that whenever your hints are given, for example, if you are given supplied with only continuity, you're supposed to use either intermediate value theorem or extreme value theorem or certain theorems pertaining to continuous functions. Okay, so a few theorems, let us start with those things and let us see. So एक चीज साफ पता लग रही है कि f of x is equal to f of x plus 1 दे रखा है for all x belongs to R. What does it imply? It implies 1 is the period of the function. So 1 is the period of the function. So 1 is the period of the function. So you have, ठीक है. Secondly, note that secondly note that the function is continuous over entire R. So what I can do, I can define a restriction over f. This is my restriction over f such that f is restricted to say interval 0, 2. Why I'm taking 0, 2? I could have even taken 0, 1, but let us restrict it over 0, 2. Okay. Now, since function is periodic, देखो function कैसा बेटा? Function periodic है. Since function is periodic, it implies range of f and f restriction are the same. इसको कैसे समझेंगे हम? देखो ऐसे समझेंगे. देखिए, मान लेते हैं फंक्शन ऐसा है, 0, 1 पे जिस तरीके से बिहेव करेगा वैसे ही 1, 2 पे बिहेव करेगा, बिकॉज हम देख रहे हैं कि फंक्शन जो है पीरियोडिक है. So the behavior of function over 0, 1 will be same as 0, 2. So I have taken the interval 0, 2. So I can say that जैसा 0, 2 पे बिहेव करेगा वैसा एंटायरली बिहेव करेगा एंटायर रीजन पे, एंटायर आर के ऊपर. क्यों? क्योंकि देखिए फंक्शन अगर यहाँ पर से फॉर एग्जांपल मैक्सिमा या मिनिमा अटेन करता है, से फॉर एग्जांपल यहाँ इसकी मैक्सिमम वैल्यू 1 है, -1 है, तो सिमिलरली 1, 2 पे भी 1 और -1 रहेगा क्योंकि फंक्शन पीरियोडिक है. लाइक से फॉर एग्जांपल फंक्शन इस तरीके से कुछ वैल्यूज रखता है, तो ऑब्वियसली बात है 1, 2 के बीच में भी उसको इसी तरीके से कुछ वैल्यूज नोट करनी पड़ेंगे. सो अटेन करनी पड़ेंगे, राइट. एक चीज समझिए, वापस मैं दोहरा रहा हूँ, अगेन आई एम रिपीटिंग. सी, इफ फंक्शन इज पीरियोडिक देन द रेंज ऑफ द फंक्शन f and f1 विल बी द सेम. कैसे? जो रिस्ट्रिक्टेड फंक्शन हो किस पे? 0, 2 पे. 0, 2 पे फंक्शन 0, 1 और 1, 2. देखिए 1 इसका क्या है? पीरियड है. 1 पीरियड है तो इट विल रिपीट इन द पीरियोडिसिटी ऑफ 1. सो जैसे फॉर एग्जांपल sin x है तो 0, 2 पाई के बीच में π/2 पे 1 भी आता है, पाई पे 0 आता है. सो सेम साइकिल रिपीट्स फॉर 2 पाई से लेकर 4 पाई. सो इस तरीके से समझेंगे. मैंने क्या किया? रिस्ट्रिक्ट किया. सो आई हैव रिस्ट्रिक्टेड द फंक्शन ओवर द इंटरवल 0, 2. पॉइंट नंबर 1. अच्छा, पॉइंट नंबर 2 आप समझिए, जब भी कभी इस तरह का एग्जाम में हिंट हो ना f of x naught plus pi, सो आप एक एडिक्वेट, एक गुड फंक्शन आप अज्यूम करेंगे, एक अप्रोप्रिएट फंक्शन अज्यूम करेंगे. सो अज्यूमिंग अ अप्रोप्रिएट फंक्शन इज आल्सो इंपॉर्टेंट. सो लेट अस स्टार्ट. सो देखिए, लेट अस कंसीडर फंक्शन टू बी डिफाइंड ओवर, लेट अस कंसीडर function to be defined over 0, 2 to R, and since function is defined over closed and bounded set, so this is your closed and bounded set, so your function range of f will also be closed and bounded. So range of f must be closed and bounded, by which I mean function will attain both maxima and minima. So f will attain its bounds, and by which I mean f will attain maxima as well as minima. Attains maximum and minimum, पहली चीज. ओके, ये चीज समझते हैं. सो या तो ऐसे समझ लीजिए, या देखिए एक थ्योरम होता है, इफ एफ आर टू आर इज कंटिन्यूअस. एक और मैं थ्योरम लिख देता हूं अगर आपको याद हो तो. इफ एफ आर टू आर इज कंटिन्यूअस such that f of x is equal to f of x plus p, where p is some positive number, that is if function is periodic and function is continuous, that implies f is uniformly continuous. तो ये चीज आप देखिएगा, इसका प्रूफ आपको मिल जाएगा स्टैंडर्ड टेक्स्ट बुक्स के अंदर. तो अगर यूनिफॉर्म कंटिन्यूटी का आपको आइडिया हो तो, अदरवाइज जैम के सिलेबस में नहीं है. f is uniformly continuous, और अगर f uniformly continuous है and f is defined from b to r, where b is a bounded subset of r, where b is bounded subset of r, then the range of f is also bounded. ये चीज समझनी है. तो ये चीज दो थ्योरम्स है जो यूनिफॉर्म कंटिन्यूटी से जिनका लेना देना है. अगर आपने नहीं पढ़ा है तो कोई बात नहीं, यू कैन स्किप. सो अदरवाइज इन जनरल आप चाहे तो यूनिफॉर्म कंटिन्यूटी का सारा ले सकते हैं. दैट यूनिफॉर्मली कंटिन्यूअस फंक्शन मैप्स अ बाउंडेड सेट टू अ बाउंडेड सेट. या तो ऐसे समझिए, ऐसे ना समझ में आता हो तो बेसिकली आप ये समझिए कि फंक्शन अगर क्लोज एंड बाउंडेड सेट से डिफाइंड है एंड कंटिन्यूअस है तो उसका रेंज जो होगा वो भी क्लोज एंड बाउंडेड होगा. दैट इज द कंटिन्यूअस इमेज ऑफ अ कॉम्पैक्ट सेट इज कॉम्पैक्ट. ओके, पहली चीज. ओके, सो पहला जो ऑप्शन है आपका, फर्स्ट ऑप्शन दैट हैज बीन गिवन इन योर एग्जामिनेशन इज f is not necessarily bounded above. So f is bounded above. कैसे? Because if it is bounded in the range 0, in the domain 0,2, since function is periodic, the same behavior or the same range will be of the f over r. Since function is periodic, since f is periodic, what I can say? I can say the range of the restricted function and f will be the same. So clearly the function will be bounded. So f is not necessarily bounded above, is rejected. So option number 1 is rejected. Now remains the other options. So how to do these questions? How to do this question? Let us assume at x equal to capital M and x equal to small m, f attains मैक्सिमा एंड मिनिमा रेस्पेक्टिवली. मान लेते हैं फंक्शन क्या अटेन कर रहा है, मैक्सिमा या मिनिमा अटेन कर रहा है. कौन से पॉइंट पे? कैपिटल एम और स्मॉल एम पे, जहां पे एम एंड स्मॉल एम बिलोंग्स टू 0,2. नाउ लेट अस अज्यूम अ फंक्शन फ्रॉम 0,2 to r given by f of x plus pi minus f of x. Now as you can see that capital M and small m happens to be the maximum and minimum value at points where function assumes maximum and minimum value. So what about gm? So gm I can write it as f of m plus pi minus f of capital M. So in general, since fm has the maximum value, so see at 0,1 if capital M is that point where function assumes the maximum value, so m plus, so clearly in 1,2 also the same maximum value will be achieved at a periodic interval of say 1. Okay, or this is how it will be. So point is this: if I am saying at the interval 0,2 it is achieving maximum value at say capital M, so whatever that particular value will be, the same value will be in the interval say 2,4 also, because function is periodic with periodicity 1. Okay, so what I can say, f of m will be the maximum value, so obviously f of m plus pi can be less than or equal to f of m. F of m plus pi can be less than equal to f of m, so that is f of m plus pi minus f of m will be less than equal to 0, and g of small m will be equals to f of small m plus pi. And since at small m f of m will have the minimum value, so what I can say is this can be greater than equal to 0. Okay, I hope you will understand this, because see, this is the maximum value, this is the supremo of the function over that particular interval. Now you can also say that this particular thing, see, can it be equal to 0? I don't know, possibly yes, but in general I can write, if it is equal to 0 then there is nothing to prove, because in that case m is that requisite x naught. If it is not the trivial case, that implies by intermediate value theorem, since g will be a continuous function, because sum of two continuous function is always a continuous function, so since g is a continuous function, so by intermediate value property there exists x naught such that g of x naught will be equals to 0. That implies f of x naught plus pi equals to f of x naught for some x naught belongs to 0 comma 2. So for some x naught belongs to 0 comma 2, you have this. Similarly, there will exist some x1 belongs to 2 comma 4 such that f of x1 plus pi is equal to f of x1. The same steps you are going to apply. Since 2 comma 4 you take closed interval 2 comma 4, so function will attain maxima and minima. The same approach of intermediate value property, you can find that there exists some x1 belongs to 2 comma 4 such that f of x1 plus pi is equal to f of x1, so on and so forth. So I can write there exist infinitely many x naught such that f of x naught plus pi is equal to f of x naught. So I hope everybody would have got this particular solution. If there is some doubt, please do comment. Okay. Now let us move to another question. This is question number, I believe, 4. Okay, and there was a slight error when I was doing it earlier. Now I'm coming up with the easier version of it. So there is a question that has come in the examination regarding integral. So asked is f is defined from R to R such that for all x belongs to R, integration 0 to 1 f of xt dt is given to be equal to 0. Okay, so how to go about this particular problem? See, let us take x to be non-zero arbitrary real number. अपन मान लेते हैं कि x जो है कोई arbitrary non-zero real number. Okay, arbitrary is important because if it is true for some arbitrary x, then it is true for all real non-zero x. This is what the logic will be. So let x be non equal to 0. That implies, let us assume that xt equal to 0. Now we have fixed it. Initially we have fixed it. Now since it is arbitrary, so for some particular x it is true, then for all x it is true. This is how the logic will be. Since it is true for any arbitrary real number, that is, initially fix it up and then generalize it all for all x. Okay, this is how it will be. आप इनिशियली क्या करें, हम फिक्स कर रहे हैं और बाद में क्या करेंगे, आप जनरलाइज करेंगे ऑन द आर्ग्यूमेंट ऑफ आर्बिट्रीनेस. मतलब आप कह रहे हैं कि x को कोई आर्बिट्ररी पॉजिटिव नॉन जीरो रियल नंबर ले लीजिए, देखते हैं कैसे बिहेव करता है. लेट अस सी हाउ फंक्शन बिहेव्स इफ आई एम टेकिंग x टू बी अ आर्बिट्ररी नॉन जीरो रियल नंबर. सो एक बार लेके देखते हैं. And once if I know that acha for every arbitrary non-zero real number it behaves certain way, then I can say that for all non-zero real numbers it will behave the same way. So this is how it is. Okay, so let xt be equals to u. That implies dt will be equals to what? Du upon x. So इसका मतलब जो आपका इंटीग्रेशन 0 से लेकर 1 f of xt dt है, that I can write as इंटीग्रेशन 0 से लेकर x fu du upon x. So implies it equals to 0. That implies integration from 0 से लेकर x fu du is equal to 0. पहली चीज, this is how it is. Secondly, आप एक चीज समझेंगे कि let us assume that f of x is equal to 0 से लेकर x fu du, और ये किसके बराबर है? 0 के बराबर है. It implies f dash x will be equals to f of x equal to 0. Now here x is any arbitrary non-zero real number. So for any arbitrary non-zero real number, you are getting your fx to be equal to 0. That implies fx is equal to 0 for all x such that x is non-zero. Since it is true for any arbitrary real non-zero number, so it is true for every non-zero real number. That is fx is equal to 0. अच्छा, साथ ही साथ क्या दे रखा है? fr2r कैसे दे रखा है? fr2r is continuous. Since fr2r is continuous, that implies f of 0 can be written as limit h tends to 0 f of h, and since for every arbitrary non-zero real number function is 0, that implies f of 0 is also equal to 0. What does it imply? It implies your fx is equal to 0 for all x belongs to R. Regards 0, you could have also done that. You could have simply placed x equal to 0 in your question, and that would have given you f0 dt integration from 0 to 1 equal to 0 implies f0 equal to 0. So in short, the answer should be fx is equals to 0 for all x belongs to R. So f is identically 0. F is identically 0 on the whole of real number line. On whole of real number line. So this is how it is. Okay. So now moving ahead to another question that has come in the examination, and this is from double integral. So question number 5. Okay. So question number 5, IPT integral over dt, where dt is a closed disk of radius 1, of radius t. It is a closed disk of radius t. Okay, so what is that? So this is dx into dy divided by p square plus x square plus y square raised to power p. So how to go about this particular problem? Since the symmetry dictates, what does symmetry dictates? Symmetry dictates that we must use polar coordinates. What should we use? We should use polar coordinates. So if I use polar coordinates, what is going to change? See, if I'm writing IPT and I'm using polar coordinates, then what I'll be getting? I'll be getting r dr d theta divided by p square plus r square raised to power p, theta varying from 0 से लेकर 2 pi and r varying from 0 से लेकर t. So this is how it is. So ultimately what you are going to get? You are going to get pi integration 0 से लेकर t. You are getting 2r dr divided by p square plus r square raised to power p. Okay. Now certainly you can generate two cases from here. One case can be p equals to 1 and one case can be equal to p not equal to 1. So if p is equal to 1, then the answer to this particular problem will be log of 1 plus t square. This you can evaluate yourself, because if p is equal to 1, then 1 plus t square, because then p equal to 1, this is 1 plus r square 2r dr dt upon t log t. Okay? So this is the case, and clearly as t tends to infinite, pi log of 1 plus t square will tends towards infinity. So therefore here you will get a divergent answer. Okay, what if p is equal to 1? Now if p is equal to 1, then your integral will be equals to pi p square plus r square raised to power 1 minus p divided by 1 minus p from 0 to t. So there it is. I believe I'm not writing it wrong. So this will be equal to pi upon 1 minus p. What you will get? You will get here 1 upon t square plus p square raised to power p minus 1 minus 1 upon, I think if you place 0 here, so you'll get 1 minus p is kept aside. So what you'll get? You will get p raised to power 2, p minus of 1. So this is what you are going to get. So as t tends to infinite, this particular term goes towards 0. So at the end, what you will get? You will get pi upon p minus 1, p raised to power 2, p minus 1. So you will get a finite answer provided your p is greater than 1. Because if p is less than 1, then this particular quantity will tend towards infinity as t tends to infinity. So your p should be greater than 1. So therefore the correct answer should be the integral is IPT, that is the integral, parametric integral which depends upon t, is finite only if p is greater than 1. Okay, so now moving to the next question, that happens to be an easy question. So this is a question evaluation of, I believe, limit, and this is an easy question. So इस साल जो question limits में है, both of them are quite certainly very easy. One, I think 3 questions हैं limit के ऊपर, और तीनों question आसान हैं और इतने difficult नहीं है in the sense, मतलब आप कर सकते थे इन तीनों question को. देखते हैं, एक मिनट, just give me a minute, okay? Let me find the question. Yes, so just give me a minute. Okay, so let us find question number 16 now. This is question number 16. Given s is equals to 1 minus 1 upon 2 square, 1 minus of 1 upon 3 square, 1 minus of 1 upon 4 square. जब भी ऐसे क्वेश्चन है, आप 4-5 टर्म आगे लिख के देखिए. 1 माइनस ऑफ 1/5 स्क्वायर डैश 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 1 माइनस 1/n-2 का होल स्क्वायर। इतने टर्म्स जब तक नहीं लिखेंगे तब तक आपको प्रॉपर आइडिया नहीं लगेगा, इसलिए मैं हमेशा ये सारे टर्म्स लिख देता हूँ, ठीक है। नाउ लेट अस स्टार्ट विद द क्वेश्चन। कैसे करना है इस क्वेश्चन को, देखिए दिस इज इजी क्वेश्चन, दिस यू वुड हैव इजीली अटेम्प्टेड इन योर एग्जामिनेशन। सो s इज इक्वल टू 1 माइनस, मैं ऐसा लिख रहा हूँ 1 माइनस 1/2 इंटू 1 प्लस 1/2, फिर मैं लिख रहा हूँ 1 माइनस 1/3 इंटू 1 प्लस 1/3 इंटू 1 माइनस 1/4 इंटू 1 प्लस 1/4 इंटू 1 माइनस 1/5 इंटू 1 प्लस 1/5 इंटू 1 माइनस 1/n-2 इंटू 1 प्लस 1/n-2, फिर आएगा 1 माइनस ऑफ n-1 इंटू 1 माइनस ऑफ n प्लस n-1 इंटू 1 माइनस ऑफ 1/n इंटू 1 प्लस 1/n. Okay, so now let us write. So s will be equals to what? 1/2 into 3/2 into I think 2/3 into 4/3 into 3/4 into 5/4 into 4/5 dash dash dash. Here you will get n-3 divided by n-2 into n-1 into n-2 into n-2 divided by n-1 into n divided by n-1 into n divided n-1 divided by n into n plus 1 divided by n. So this is how you are getting it. Okay, so okay, this is how you are getting it. Okay, now let us make some pairs. So देखिए अगर आप इस टर्म को छोड़ दें और इस टर्म को छोड़ दें, you are seeing that there are pairs. See, this pair is giving you 1, this pair is giving you 1, this pair is giving you 1. So certainly here it is n-2, here it will be n-2, here it will be n-3. So this pair is 1, again this pair is 1, and this pair is also 1. So certainly you are left with only 1/2 and n plus 1 divided by n. As n tends to infinity, this particular term goes towards 1. So therefore answer to your problem should be half. So I believe this is an easy question that you could have easily attempted in your examination. Now moving ahead to another question that has been asked in the examination, and that happens to be a question of Newton-Leibniz formula. So question number 21, this is a question from Newton-Leibniz formula, and again it is an easy question. Let us see how to approach this particular problem. Okay, let us see how to approach this particular problem. Okay, so that question that has been asked is f is defined from 0,1 to 0,infinity. Okay, and ft का whole square is less than 1 plus 2 integration from 0 से लेकर t fs ds. देखिए इस साल इन लोगों ने थोड़ा सा चेंज कर दिया, बाकी है ये न्यूटन लिबनिट्ज का क्वेश्चन, ठीक है। सो न्यूटन लिबनिट्ज फॉर्मूला आपको जैसा कि आता ही होगा, यू जस्ट स्टार्ट डिफरेंशिएटिंग ऑन बोथ साइड्स। तो अब प्रॉब्लम क्या होगा, जस्ट डोंट डिफरेंशिएट, लेट अस टेक दिस पर्टिकुलर वेरिएबल एज समथिंग। सो लेट अस टेक दिस पर्टिकुलर वेरिएबल एज g of t. So let us take this particular variable as g of t. So g of t will be equals to 2 plus integration 0 से लेकर t f of s ds. Okay, f of s ds. Okay, now g dash t will be equals to what? 2 times f of t. Okay, this is 2 times f of t. Okay, and okay, and lower limit will be 0. ठीक है. So in short, g dash t will be equals to 2 times f of t. And what is f of t? So f of t, since it is less than I think this, I can write f of t, 2 times f of t will be less than so what I can write, okay, just give me a minute. So g dash t I can write as 2 times f of t, and f of t, okay, I can write this particular thing as f of t. Since we are talking of only on the positive side, so I can write f of t be strictly less than root over g of t. So I'm not using plus minus here because ultimately you have to answer only in the, because your range of the function is throughout positive. So your ft must be positive and it should be less than root over g of t. Okay, so this is how it is. So I can write your f of 2 times f of t will be less than 2 times root over g of t. पहली चीज, your first equation. नाउ कमिंग बैक टू, थोड़ा सा अगर हम सोचे g0 किसके बराबर, देखिए g0 किसके बराबर है, g0 है आपके 1 के बराबर। थोड़ा सा ध्यान से देखना, g0 किसके बराबर है, 1 के बराबर। अब आप पूछेंगे g0 क्यों निकाल रहा हूं, क्योंकि देखिए थोड़ा सा दिमाग लगाते हैं, अगर मैं बात करता हूँ एफ ऑफ टी की, तो बेसिकली मुझे बताना है एफ ऑफ टी और 1 प्लस टी के बीच में रिलेशन। सो एफ ऑफ टी किसका बराबर, रूट ओवर जी टी के बराबर है, ठीक है। अगर मान लीजिए मैं इसको इंटीग्रेट करता हूँ तो मुझे कैसे क्या करना पड़ेगा। सो मैं एक काम करता हूँ, मैं एक जानबूझ के टर्म लिखता हूँ रूट ओवर जी टी माइनस 1, which happens to be इंटीग्रेशन फ्रॉम जीरो से लेकर टी, यहाँ पे लिख सकता हूँ मैं जी डैश एस डिवाइडेड बाय 2 टाइम्स रूट ओवर जी एस डी एस। थोड़ा अगर ध्यान से देखेंगे तो 1/2 रूट एक्स का डेरिवेटिव कितना होता है, रूट ओवर एक्स, तो रूट ओवर जी टी और टी पे जी टी आ गया, रूट ओवर जी टी और जीरो पे आ जाएगा 1। सो दिस इज हाउ आई हैव मैनिपुलेटेड। अब आप बोलेंगे इस तरीके से क्यों मैनिपुलेट किया, इस तरीके से इसलिए मैनिपुलेट किया है बिकॉज आई हैव अ रिलेशन दैट जी डैश टी इज लेस देन 2 times root over gt. So as we know that g dash t divided by 2 root over gt is less than 1. So I can write simply that root over gt minus 1 is less than 1 integration 0 से लेकर t ts. So your answer will be equals to root over gt will be less than 1 plus t. And what is root over gt? So you can clearly see that root over gt and this. So f of t is less than root over gt and it is less than 1 upon t. So that implies f of t will be less than 1 plus t for all t belongs to 0, 1. So therefore I can clearly see that f of t is less than root over 1 plus t. So your option number 1 I believe is the correct answer. ओके सो ये थोड़े से आसान क्वेश्चन थे जो आप कर सकते थे। आई बिलीव, आई थिंक थोड़ा सा डिफिकल्ट हो पाया था। आई थिंक दिस इज द फर्स्ट आंसर, ठीक है। सो ए ऑप्शन, क्वेश्चन नंबर 21, दिस इज हाउ यू शुड बी डूइंग द क्वेश्चन। ओके, नाउ लेट अस मूव ऑन टू अनदर क्वेश्चन that have been asked in the examination, and this is a really good question. See, this is a really good question. This is question number 26. Now given that question number 26, f is defined from 0, 1 to 0, 1, be a non-constant continuous function. This is a non-constant continuous function. This is a non-constant continuous function such that f of f is given to be equals to f. So f of f is given to be equals to f and asked कि ef जो होगा उसके बारे में आप क्या कह सकते हैं। So your ef is equals to x belongs to 0, 1, 0, 1 such that fx is equal to x. ये थोड़ा सा अच्छा क्वेश्चन है, देखते कैसे करते हैं इसको, थोड़ा समझदारी से करेंगे। सो कंसेप्ट क्या लगेगा, कंसेप्ट अगेन हम लोग लगाएंगे इंटरमीडिएट वैल्यू प्रॉपर्टी और थोड़ा सा सेट थ्योरी का परसेप्शन सेट करेंगे। देखते हैं, मैं रोटेशन लिखता हूं। लेट अस कंसीडर द रेंज ऑफ फंक्शन टू बी डिफाइंड एज 0, 1. सो f since x the domain है 0, 1 है, so let's say range of f is equals to f defined over 0, 1. So range, let rf denote, मैं ऐसे लिख देता हूं, let rf denote the range of the function, range of f. Okay, now since function is defined over a compact enclosed set, so f is a continuous function defined over a compact set, so I can say that f must be a closed and bounded set, or I can say that continuous image of an interval is an interval. So continuous image of an interval is an interval by intermediate value property, of an interval is interval. So basically this follows from intermediate value property. So I can say that your range of f must be an interval. पहली चीज, यहाँ तक कोई दिक्कत नहीं, क्योंकि जो ऑप्शन में पूछा जा रहा है उस हिसाब से मैं कर रहा हूँ। बिकॉज ऑप्शन में पूछा जा रहा है EF is an interval, EF is non interval, EF is empty, EF is neither closed nor open, इस तरीके से क्वेश्चन पूछे गए, दैट इज व्हाई। तो सबसे पहले देखते हैं EF हमारा कहीं ऐसा तो नहीं एम्प्टी सेट है। सो लेट अस सी दैट वेदर और नॉट EF is empty. सो देखिए यहाँ तक ठीक है, रेंज मस्ट बी एन इंटरवल बाय इंटरमीडिएट वैल्यू प्रॉपर्टी। ओके, नाउ लेट्स से y is equal to f of x, और f of x कहाँ से पिक कर रहा हूँ मैं, रेंज से, ठीक है। सो आई एम पिकिंग इट फ्रॉम रेंज ऑफ f. So let y is equal to f of x and f of x belongs to range of f, and given that दे के रखा बच्चों लोग, दे रखा है f of f किसके बराबर दे रखा है, f of x के बराबर दे रखा है, it implies f of y is equals to y. f of y किसके बराबर दे रखा है, y के बराबर. Now according to the definition EF कैसा सेट है, for x belongs to 0 comma 1, if f of x equal to x, then all such x are contained in ef of f. It implies y is contained in e of f. So therefore I have chosen an element from the range of function f. So y, ultimately what I have achieved, that y belongs to ef of f. That implies ef cannot be an empty set. So clearly the option number C is rejected, that is ef is empty, this is rejected. Okay, now let us move to another thought. Okay, so एक चीज पता चल गई, y belongs to ef of f. Since y belongs to e of f, ठीक है, y belongs to e of f. Now since y belongs to e of f and y is nothing but it is equals to what, f of x. So what I can write, that your range set must be contained in e of f. So your range set must be contained in e of f. So ultimately what is y? Y is element from range set where x belongs to 0 comma 1. So your range set is contained in e of f. So this is your argument number 1. Also मानते हैं कि let x belongs to e of f, मान लेते हैं कि let x belongs to e of f. Now since x belongs to it implies what? If x belongs to e of f, it implies x belongs to x comma 1 such that f of x is equal to x. So it implies what? Since x is equals to what, f of x, and x belongs to 0 comma 1, it implies x also belongs to range of f, because x happens to be equal to what, function of image of f. X happens to be equal to what, it happens to be equal to the image of f where x belongs to 0 comma 1. So what is x? X is equals to range of f where x belongs to 0 comma 1. So if x belongs to e of f, it implies x also belongs to range of f. It implies ef can be thought to be contained inside rf, and summarizingly I can write that e of f happens to be range of f. Now since range of f is an interval, it implies ef must be an interval. So I hope आपको आंसर मिला होगा इसका. So answer to this particular problem is ef is an interval. So वापस सुन लेते हैं इस चीज को. देखिए यहाँ पे क्या किया है, f कोई एक नॉन कांस्टेंट कंटिन्यूअस फंक्शन है, provided f of f is given to be f. Now if ef is defined as all those x belongs to 0, 1 such that fx equal to x, कैसे प्रोसीड करते हैं? पहले मैंने डिनोट कर दिया rf denotes the range of f, that is f x 0, 1 जो है डोमेन है. So for all the values of domain जो भी फंक्शन इमेजेस लेता है, that I am denoting as rf, that is the range of f. Now देखिए f is defined over a compact set, so function must range of f must be closed and bounded set, and further otherwise also continuous image of an interval is an interval by intermediate value property. So therefore range of f must be an interval. पहली चीज. अब आगे बढ़ते हैं. अगर y fx को बिलोंग करता है, it implies y belongs to y is some element in the range of f where x belongs to 0, 1. अब गिवन क्या है, f of f fx के बराबर है, that implies f of y किसके बराबर होगा, y के बराबर. अब f of y अगर y के बराबर है, it implies ये किस सेट में कंटेन होना चाहिए, it should be contained in set ef. That implies if y is contained in r of f, that implies y is contained in e of f. So I can write that rf must be contained in e of f. Similarly, when x belongs to e of f, it implies all those x where f of x equal to x. That implies since x is equal to f of x, I can say that what is x? fx. Fx is the range of f, right? For all x belongs to 0, 1, f of 0, 1 denotes range. So since f of x is equal to x, that implies x must be belonging to range of f also. That implies since x is belonging to e of f, that implies ef must be contained in r of f. Using argument number 1 and argument number 2, I can clearly state that e of f is equal to r of f. That implies since rf is an interval, that ef must be an interval. I hope this should be the solution to this particular problem. If you have certain doubts and queries, you can just comment. You just feel free to comment, because probably while doing all these things in very hurry, there might be a chance that we may fumble. So this is a human tendency. So do tell me if there are some problems in the solutions. Okay, now moving on to question number 43. This is a question from vector calculus, or I can say multivariate calculus. So this year multivariate calculus had less flavor of calculus, more flavor of again analysis. So I've regarded these problems inside the real analysis section only. Okay. So how to go about this particular problem? This is again easy problem, but certainly not very very usual such questions you will find in your JAM examination, although in NBHM this has been a routine problem. Okay, so the question that was asked, that there was given a ball, and this ball was of unit radius. This ball was of unit radius, and there was a smooth function that was given as sine of 1 minus of x square plus y square plus z square, the whole square, and asked was Laplacian u d tau. Now coming to a concept, that is, let u be a smooth function. Now what is a smooth function? I require you all to kindly study about smooth function and write in the comment section what is a smooth function. Okay, so let u be a smooth function and BA be a ball of radius a, then del u upon del n integration ds is equal to integration del square u d tau. So if unit ball is having volume v, which is enclosed by a surface S, then del u upon del n ds is equal to del square u d tau, where n is the unit vector normal to the surface S. नॉर्मल टू सरफेस एस. कैसे करेंगे इस चीज को? देखिए आप पढ़ते हैं एफ वेक्टर डॉट एन कैप डी एस इज इक्वल टू इंटीग्रेशन डेल डॉट एफ वेक्टर डी टाउ. दिस इज योर डाइवर्जेंस थ्योरम. Okay, so if you're writing del square u, so what I can say that your del square u is del times grad of u. So del times grad of u, if I'm saying, so instead of del dot f vector, what I am having grad u. So if I'm saying what is del times del u, divergence of grad u d tau over some ball of radius r. If I'm saying it is ball of radius r, then this will be equals to what? According to the divergence theorem, this will be equals to grad u dot n cap ds, where n cap is the unit vector normal to s, unit vector normal to s. And since s happens to be a sphere, so what I can write, since it is a sphere, so I can say that your n cap is equals to what? It happens to be r cap. And what is a ds element here? So ds element will be equals to r square sine theta d theta d phi. Okay, so this is what is your ds. So this is what is your ds. Okay, so this is what your ds is. So what you will get? You will get simply del u upon del r, because n cap is equal to what? N cap is equal to r cap, and this is your ds over s, where I'm assuming that it is a unit ball of, it is a ball of radius capital R. Okay, so what is your u? Given in the question, your u is sine of 1 minus of r square ka whole square. Now you are saying how did r square came? Because since you are having a spherical symmetry to the problem, so instead of x square plus y square plus z square, I'm substituting a polar coordinate, that is r. Okay, so if you are set to find, and at this particular patch, your r is equal to capital R. So what you are getting, so if you compute, your del u upon del r will be equals to 4, that I'm leaving up to you, that you calculated. So 4r square minus 1 cos of 1 minus of r square ka whole square. So this is your del u upon del r at r equals to capital R. So this thing you are evaluating over ball of radius r. So del square u d tau, what you are getting, it is equal to integration 4 r into r square minus 1 into cos of 1 minus of r square into r square sine theta d theta d phi. So this is what it is. So ultimately what you are going to get, this is 4 pi. So what you are going to get, this is 16. So 16 pi r cube r square minus 1 into cos of 1 minus of r square. So this is something that I have generalized for radius capital R. In the question, it is given that your r is equals to 1. So if you are using r equal to 1, so your answer must be equal to 0. So I hope ये चीज आपको समझ में आई होगी. I've simply used the divergence theorem and the definition of the Laplacian, and I have achieved an answer as 0. Okay. So I hope this is something that you might have got. Now another question that has occurred in the examination regarding limits is from trigonometry, and again it is an easy question, but yes, a few people would have thought how to do this particular problem. I would suggest that such questions have been asked in JEE examination, but I'll not recommend you to go through JEE problems also, because this will be too much of expectation from child side that they do 11th 12th also and they do everything of that sort. But yes, the question has been asked. It requires a certain manipulation that you could have done if you had an experience with doing such questions. If you have not had the experience with such question, probably you would have not attempted it. Fine. Let us do the question. So question that was asked in the examination was limit n tends to infinity pi upon 2 cos of pi upon 4 times cos of pi upon 8 dash 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 cos of pi upon 2 की power of n plus 1. So such questions are very easy, certainly tackleable, but let's see how many people have done it. So in case आपको थोड़ा सा समझ में आए, तो आप जानते हैं कि जब भी कभी टेंस टू इन्फिनिटी है, ज्यादातर जो आप लिमिट्स यूज करते हैं, फॉर एग्जांपल जब एंगल्स होते हैं तो जनरली आप साइन प्रेफर करते हैं, because sin theta upon theta limit theta tends to 0 is equals to 1. Okay, so let us do this particular thing. So क्या किया हम लोगों ने यहाँ पे, just multiply it using sin of pi by 4. एक बार आप मल्टीप्लाई कीजिए sin of pi by 4 से. जब sin of pi by 4 से मल्टीप्लाई करेंगे तो विल डिवाइडेड बाय sin of pi by 4. और थोड़ा सा ध्यान से देखिए, sin pi by 4 into cos pi by 4 times 2 is sin 2 into pi by 4, that is sin pi by 2. So 2 sin theta cos theta is equal to sin 2 theta. Similarly cos pi by 8, यहाँ पे काम कर लीजिए, sin pi by 8 मल्टीप्लाई कर दीजिए, तो आपको आसानी से समझ में आ जाएगी पूरी सिमेट्री क्या है. सिमिलरली आगे बढ़े तो इधर मैं मल्टीप्लाई करता था 2 sin pi upon 16 into cos of pi upon 16 divided by 2 sin pi upon 16, and एंड में लास्ट में आ जाएगा 2 sin pi upon 2 की पावर n plus 1 times cos pi upon 2 की पावर n plus 1 divided by 2 sin pi upon 2 की power of n plus 1. So this is how it is. Okay, so what you are going to get, you are going to get pi upon 2 limit n tends to infinity, and ultimately what you are getting sin of pi upon 2 divided by 2 sin of pi by 4. Then you are getting what? Then you will be getting sin of pi upon 4 divided by 2 sin of pi upon 8. Then you might be getting sin of pi upon 8. Then you might be getting 2 times sin of pi upon 16, and in the end you are getting sin of pi upon 2 की power n, and here you will getting 2 sin pi upon 2 की power of n plus 1. So certainly what gets cancelled? Let's see, ये cancel हुआ, ये cancel हुआ, ये cancel हुआ. Similarly sin pi upon 2 की power n gets cancelled. The only remaining terms is this and this. And how many n's will be there? You can clearly see that when here it was 2 square, here it was 2. When here it was 2 cube, here it was 2. So from here to here, so how many numbers of n you will be having? This is n plus 1, this is 2. So you are starting from index 2, 3, 4, n plus 1. So from 2 से लेकर n plus 1 number of, so there will be totality n. So in totality, I can write pi upon 2 limit n tends to infinity. What you are getting is 1 upon 2 की power n into sin pi upon 2 की power of n plus 1. And at the end, if you multiply all these things, what you will get? Limit n tends to infinity pi upon 2 की power n plus 1 divided by sin of pi upon 2 की power n plus 1. As n tends to infinity, pi upon 2 की power n plus 1 tends to 0. So theta tends to 0, theta upon sin theta, it always converges towards 1. A very simple question that you would have attempted, but let's see how many people have attempted. Please do comment in the comment section how many people have attempted this particular problem. This was a fairly easy problem, but again I will say for many students it might appear difficult because they might have not have had experience to this, and for this particular reason we are saying that please join the batches as early as possible so that we can cover from basics to advanced everything. Okay, so we'll be running our JAM batches very soon. Please do join that. Okay, next question. Okay, so अगला क्वेश्चन जो पूछा गया था एग्जाम में थोड़ा सा डिफिकल्ट है. लेट अस सी हाउ मेनी पीपल वुड हैव अटेम्प्टेड इट. आई डोंट नो. दिस हैपेंस टू बी a slightly tricky question. So this happens to be slightly tricky question. this question was asked about the divergence of Fn. So let Fn be a bijective map such that summation n equals to 1 से लेकर infinity Fn upon n square is convergent. ऐसा पूछा जा रहा था, is less than infinity, that implies is convergent. So what does that imply? How many number of such bijective maps can be possible? तो question ये पूछा जा रहा है कि how many numbers of bijective maps are possible such that summation Fn upon n square is convergent. So this is certainly a difficult question. How to solve this particular question? I'll go very slow and let us start. Okay. तो देखिए, consider Fn to be permutations on n. So you might have seen permutation groups also. So permutation on n, by which I mean, see, and clearly since it is bijective, so F1, F2, F3, Fn will all be distinct natural numbers. So they will all be distinct natural numbers. f of 1 होगा, उसको मान लेते ग्रेटर देन इक्वल टू 1. सो फॉर एग्जांपल 1 पे आपकी जो फंक्शन की वैल्यू है वो मैं मान रहा हूँ ग्रेटर देन इक्वल टू 1. सिंस आई एम अज्यूमिंग at point 1 your functional value is greater than equal to 1, what I can infer for 2? I can infer for 2 that your f of 2 must be greater than equal to 2 at least, because see, if it is not the case, since it is greater than equal to 1, so it has been occupied with either 1, 2, 3, 4, so on and so forth. So what remains for 2, that f of 2 must be greater than equal to 2. So in totality I can write f1 plus f2 plus f3. That is why I've said that f of n be permutation over n. So let Fn be permutation over n, and then since f of 1, f of 2, f of 3 are all distinctively natural numbers, so in general what I can write, in general if I say that at 1 your functional image is greater than equal to 1, so in general I can write that if the functional image at x equal to 2 should be greater than equal to 2, and at n greater than equal to n. I believe I'm able to convey my idea. So in general this will be greater than equals to n into n plus 1 divided by 2. आई होप गाइज ये चीज समझ में आई होगी. पहली चीज, अच्छा थोड़ा सा एक दिमाग खर्च करना पड़ेगा यहाँ पे. n इक्वल टू 1 से लेकर इन्फिनिटी Fn अपॉन n स्क्वायर, इसको आप किससे रिप्लेस कर दो? जस्ट रिप्लेस इट बाय द पार्शियल सम. ये पार्शियल सम क्या है मैं बताता हूँ. ये पार्शियल सम है F1 प्लस F2 प्लस F3 प्लस डैश 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 Fn. इससे रिप्लेस किया इनटू 1 अपॉन n स्क्वायर माइनस 1 अपॉन n प्लस 1 का होल स्क्वायर. आप देखिए इससे मेरा क्या मतलब है. देखिए इससे मेरा क्या मतलब है, थोड़ा सा मैं साइड में ले जाके साइड में समझाता हूँ आप लोगों को. देखिए इस चीज को समझिए, इससे क्या मतलब है फिर हम देखते हैं इसको. देखिए इससे क्या मतलब है, फॉर एग्जांपल n इक्वल टू 1 ले रहे हैं तो सिंपली क्या आएगा f1, n इक्वल टू 1 लिया तो f1 1 अपॉन 1 का स्क्वायर माइनस 1 अपॉन 2 का स्क्वायर. जब n इक्वल टू 2 लेंगे तो क्या आएगा f ऑफ 1 प्लस f ऑफ 2, f अपॉन 1 का सॉरी f अपॉन 2 का स्क्वायर माइनस f अपॉन सॉरी, जब n इक्वल टू 2 लेंगे तो f ऑफ 1 प्लस f ऑफ 2, 1 अपॉन 2 स्क्वायर माइनस 1 अपॉन 3 स्क्वायर प्लस 3 लीजिए f ऑफ 1 प्लस f ऑफ 2 प्लस f ऑफ 3, और यहाँ पे क्या आएगा बच्चों लोग, यहाँ पे आएगा 1 अपॉन 1 का सॉरी 3 का स्क्वायर माइनस 1 अपॉन 4 का स्क्वायर. अब खुद सोचिए इसमें से मैं एक बार f ऑफ 1 कॉमन लेके देखता हूँ. तो f ऑफ 1 लेके देखा तो क्या है 1 अपॉन 1 का स्क्वायर प्लस 1 अपॉन 2 का स्क्वायर, ओके सॉरी माइनस 1 अपॉन 2 का स्क्वायर. फिर यहाँ से क्या आएगा f 1 अपॉन 2 का स्क्वायर माइनस 1 अपॉन 3 का स्क्वायर देन 1 अपॉन 3 का स्क्वायर, सो ऑन एंड सो फोर्थ. So what you are getting f 1 upon 1 का square. Similarly with respect to 2 if you are seeing, so you are getting f of 2 into 1 upon 2 का square minus 1 upon 3 का square, then from here you are getting plus 1 upon 3 का square minus 1 upon 4 का square, so this you are getting cancelled, so you are remained with f2 upon 2 square. So basically इस pattern को लिखना is equivalent to writing this. लेकिन इसका मजा क्या है? Why I am doing this? I am doing this because this particular thing I have an estimate. I have an estimate in mind that this particular thing must be greater than equal to n into n plus 1 divided by 2. So what I can do, I can write that this is greater than equal to summation n equals to 1 से लेकर infinity n into n plus 1 divided by 2 into 2n plus 1 divided by n का square into n plus 1 का whole square. So what I'll be getting summation fn divided by n square is greater than equal to summation n gets cancelled with n plus 1 gets cancelled with n plus 1. So what you're getting, it is greater than equal to 2n plus 1 divided by n into n plus 1 divided by 2. So basically this is greater than equals to summation 1 upon n, and since this happens to be a divergent series, therefore this is divergent. So number of bijective functions such that fn upon n square is convergent is none. So answer is none. अब आप बोलेंगे आपने इसमें सारे bijective maps कवर कर लिए. हाँ, कैसे कवर कर लिए? by saying that fn be the permutation on n. When I'm saying fn is a permutation on n, the possible images for f1 can be 1 2 3 4 5 6 7 8 9, क्योंकि it is a map from n to n. So the question में दे रखा था this is a map from n to n. So all possible images for f1 can be 1 2 3 4 5 6. Since I have used 1 here, so I have restricted 1. So what I can do basically, and also that it is a bijective map. Say for example, without loss of generality, let us assume that it is an increasing map. Then f of 2 is bound to start from 2 3 4 5 6 so on and so forth. So basically by this particular methodology you could have done the question. Many people have used fn is equal to n, possibly that you could have done in your examination. I have no issues, but to contradict with some other example will again be an issue. So probably more general approach will be to do this way, and let us see if there are doubts. So if you have certain doubts, please do share and do comment. Okay. Next question that we are using is again from integral calculus, or should I say that it is from integral inequalities. So this particular problem is from integral inequality, and certainly this is a blinder, because usually as a JAM classroom you used to do Cauchy-Schwarz inequality, we used to do arithmetic mean greater than equal to geometric mean, we used to do integral form of Cauchy-Schwarz inequality, we used to do Young's inequality. So whenever we teach at ARYA classes, we teach inequalities as the first topic of real analysis, but certainly this we have not taught. So see, the level is increasing, and since it is increasing, you need to join early. Time and again I am saying the same. So please join early and you will be benefited a lot with our teachings, guiding, and on ARYA classes you have test series, you have everything that you can use. Okay. So this is a question पूछा जो जा रहा है आपसे. This is a question that has come in the examination, and certainly again a difficult question for students, because probably they are not very used to this particular problem. That is why certainly difficult, but let us see how to approach this particular problem now, since it has been asked in the examination. So this question happens to be a question from Young's inequality. So question पूछा जाता है largest. So straight cut I am writing the inequality, I am not deriving it. If you need the derivation to this particular problem, I can derive it. You can again write in the comment section that please derive it. So I'll derive it, no issues. So the largest positive number, let me derive it. Positive number a such that integration 0 से लेकर पूछा जा रहा है 5 fx dx plus integration 0 से लगाकर 3 f inverse x dx is greater than equals to a, then what is the value of a? So answer is 15. So this answer is 15. How to go about this particular problem? पहले देखते हैं. So there is established inequality that is called as Young's inequality. What it is called as? It is called as Young's inequality. So if you need a valid proof to it, how do you start? You start from the question that suppose f belongs to class 1 functions. Again, do tell me what are class 1 functions. What are class 1 functions? Do tell me on the comment section. Okay? If f is defined on f belongs to class 1 function over 0 comma c, where c is some positive real number and it is strictly increasing, is strictly increasing such that f0 is equal to 0, then integration 0 से लेकर x ft dt plus integration 0 से लेकर f of x f inverse t dt is equal to x into fx. इसको कैसे करेंगे? देखिए ऐसे करेंगे, सिंपल है. लेट अस स्टार्ट. देखिए क्या कीजिए, just take this particular thing as u. So taking u is equal to f inverse t, what you are getting t is equal to f of u. So what I can write integration from 0 से लेकर x f of t dt, and here I can write integration u into f dash u du varying from 0 से लेकर x. So by parts integration here, what are you supposed to get? You are getting 0 से लेकर x f t dt plus integration at integrating by parts, what you are going to get, you are getting f into u into fu minus integration from 0 से लेकर x, and from here 0 से लेकर x you are getting 1 and you are getting fu into du. So this particular term gets cancelled. So ultimately what you are left with, you are left with x into fx. So your integration 0 से लेकर x f t dt plus integration 0 से लेकर fx f inverse t dt happens to be equal to x into f of x. So this happens to be x into f of x. This is the first result that you should remember. This is the first result that you should remember. Now if you are given 0 to a f t dt plus integration 0 से लेकर b f inverse t dt, then what to do? So without loss of generality, let us assume that your f of a is less than b, and let b be loss of generality, let us assume that fa is less than b. Okay, I believe this is clear to you. So b is the image of function at x, and let us assume that fa is less than b. So this particular b, this particular integration I'll remain as it is, and let us see what is the value of this particular thing, what is the inequality that follows. So what I'll do, I'll divide it into segments, this plus integration f of a to b को मैं लिख दूंगा f of x, and here I'll write f inverse t dt. याद कीजिए अभी 2 मिनट पहले मैंने इसको क्या लिखा है, I have written this particular thing as x into fx, so this will be equals to a into f of a plus, now integrating में इसमें क्या लेंगे, f inverse को आप ले लीजिए u, that implies you are integrating it from a से लेकर b, you're getting u into f dash u into du, and what you are getting, you are getting ultimately a into fa plus x. Okay, so what you're getting, you're integrating it, so you'll get x into f of x from u into fu from a से लेकर x minus integration fu du from a से लगाकर x. Okay, now you are supposed to generate an inequality from here. So what you're getting a into fa plus x into fx minus a into f of a, and since function is given strictly increasing, so whenever your u is lying between x and a, so I can write your fu will be less than equal to fx and lies between fa. Since function is given to be strictly increasing, so I can write this way, and minus of fu is greater than equal to minus of fx, and this is how I can write. So what I can do instead of this particular thing f of a, I'm writing it all here like this way. Now what I'll do, I'll replace minus of fu by minus of fx. So what I'm getting, a into f of a plus x into f of x minus a into f of a, and here you are getting, I can write greater than equals to minus of fx. Since fx, if I'm replacing here, it is being integrated with respect to u, so what you're getting, x minus a. So ultimately I can write your required integral that is asked in your examination is greater than equals to a of f of a plus x into f of x minus a into f of a minus x into f of x plus a into f of x. So what you're getting all these things as cancelled. Now since f of x, I have already told you this is equals to b, so your required integral is greater than equals to ab, and in your case happens to be a equals to 3 and b equals to 5, that implies ab equals to 15. So if your integral is given to be greater than equal to a, so that particular a happens to be 15, I believe. Okay, so let me see the answer to this particular problem. So I think 15 should be the correct answer. Let me see, this is your question number 54. So kindly note that this is your question number 54. Question number 54, the answer is 15 only. Okay, so this is your question number 54. Okay, this is your question number 54. I believe यहाँ तक सभी लोगों को समझ में आया होगा. Okay, so this is the question, this is the answer. So I hope आज की क्लास में सब चीजें समझ में आई होंगी, and we'll meet tomorrow again with certain more problems of JAM 2021, and certainly there is another examination like TFR Indian Statistical Institute, so we'll be solving those problems for you online and you will be seeing how to approach the problems. Okay, so kindly join our batches for JAM and do think, if I'm again stating that if you're getting around 45 to 50, probably around 50, I think it will be a safe score, but still keep studying, keep doing well. Thank you.